Yeah. Let's see, from over here, another question?
Hi, I'm Yotam Ariel, founder and CEO of Bluefield. We are deploying methane tracking microsatellites. And my question to you, I hope to learn your thoughts on advancing remote sensing capabilities of critical gases on Earth and on Mars. Thank you.
Well, that's a pretty esoteric question. Remote sensing of gases, yeah, I think that's something that's going to be important. Mars has a number of trace gases that are pretty helpful. It's very helpful that Mars has CO2 and nitrogen and argon. Those are like really helpful gases to have in the atmosphere. It's mostly CO2, but that little bit of nitrogen and argon is really going to be pretty helpful. Yeah. And and whatever other trace gases we can get out of the atmosphere.
I don't know. We always say Mars has just enough atmosphere to. It's not enough to be really helpful in terms of aerobraking, but it sure makes it a lot harder. So it's just enough to be difficult. So,
yeah.
but in terms of in situ research utilization, you know, when we get there to be able to build to get your oxygen and hopefully we'll have water that can get hydrogen, manufacture hydrogen on the planet. So hopefully there's enough resources we don't have to carry everything with us.
Well, the nice thing, you know, if you got H2O and CO2, you can build hydrocarbons of any kind. So you can build plastics. You can build short chain, long chain hydrocarbons. The current SpaceX thought for kind of a Mars transport vehicle is a primarily methane-based system, because you get to have a kind of a smaller. I mean, the tanks are half the size with methane. And Mars with a CO2 atmosphere and a lot of water ice is great for that. Going beyond Mars, I think there's a lot of merit for hydrogen, because then you only need water. But that's our sort of current thinking on